So for the last few months, there's been rumors about this inverter, and today it is finally released. This is the new EG4 6000 XP by Lugs Power. So it's like an 18K, but smaller. But it's not that expensive. This is gonna be competing with the LV6548s and the 6500EX, but it has a lot of features that those do not have. Also, the software and interface should be better compared to those older models. Also, it has a lower idle consumption compared to the competition. One YouTuber, Lithium Solar, he got the new LV6548, the latest version, and it had 100 watt idle consumption. This one is under 50, so that's going to be huge for this size of inverter. Next, it has a split phase output. You'll notice on this load center with the breaker, you have a load 1 and a load 2. So you have 120 and 240 volt. That means you can run 240 volt heat pumps and other loads with this unit all by itself. If you tried to run a 240 volt load with the older models, you would have to buy 2 of them and then put them into parallel with communication. Now you just hook this up on your wall and you're good to go. Next, unlike the older models, this one has its own circuit breakers, and this makes the installation faster and also cheaper, because these are not cheap, especially DC rated resettable circuit breakers. On older models, if you had multiple units on your wall, for each unit you had to buy your own T-class fuse for the battery connection or a resettable DC rated circuit breaker, and then for each AC output you had to supply a circuit breaker at the load center where you connected them all together. And that costs a lot of money, and you have to wire all of that stuff up yourself. Also, it comes with the disconnect switch for the PV input, so you also don't have to buy that as well. So if you think about it, this system is very easy to install and a lot cheaper for most people. Next, it has closed loop communication with the Power Pro battery, the large vertical mount 14 kilowatt hour, or with the server rack batteries by EG4. So it comes with a cable, you plug it into this unit, and then you plug it into the battery, and that's pretty much it. With the Power Pro, you have to set it up though. You have to make sure that it says Lugs Power for the communication protocol, and then you'll be good to go. Now, the app on the phone that's used to monitor this system and control the settings, you can also now do remote firmware updates. You could not do that with the older models because they had a completely different system. You'd have to do a serial to USB, and then you'd have to connect it with a computer with a certain operating system, and then update the firmware manually. On this one, you can do it over Wi-Fi after you plug in the Wi-Fi dongle. For some people that think of that as a security concern, you don't have to do that. You don't have to update the firmware. You don't have to do anything else. You just do not plug in that little dongle and you'll be good to go. And actually, the Wi-Fi dongle is down here. It's been holding it up for this whole video. And it looks just like the 18K. You just plug this in and then screw it in, and it's waterproof. There's a seal. Now let's talk about the basic functionality of this unit, the inverter, the solar charge controller, and everything else. First off, the inverter can output 6,000 watts, but that's in a split phase configuration. And it has a massive surge capacity of 12,000 watts for 25 seconds. So it's very similar to the 18K. The 18K surge capacity for a high frequency transformerless inverter is also just as massive as this relative to the size. But for single phase 120 volts for each leg, it can only do 3,000 watts. So this is designed to be used as a split phase inverter. Also, this inverter has the lowest idle consumption, which I mentioned earlier. It's under 50 watts. But if it's connected to solar and it's charging, the inverter's efficiency increases and it's only 30 watts for idle consumption. And if you have it connected to AC as a UPS backup, it only uses 10 watts. Because it will turn off the inverter and it will only turn it on when it needs to supplement that power. Also, the inverter efficiency from the battery to the AC output is 93.5%. Most of these size inverters is 88 to 92%. So it's supposed to be the most efficient inverter in its class. And the better efficiency, the less batteries and solar panels you need to buy. Now let's talk about the solar charge controller. There's 2 trackers or 2 PV inputs, and each one can handle 4,000 watts. So the maximum input is 8,000 watts of solar panels, and that's at 480 volts maximum PV input voltage. And that circuit is 99% efficient, but that's pretty common for MPPTs. Now what you do need to know about the MPPT is the minimum operating voltage. So you need to have enough panels in series to create at least 120 volts DC for this to start charging the batteries and running the inverter with that solar power. So the voltage range is 120 volts DC to 480 volts DC. They actually recommend a maximum size array of 10,000 watts. So as long as you don't exceed 480 volts DC, you should be good to go. And personally, I recommend after wiring up lots of these systems, start with a minimum of 200 volts. That way in the morning and the late afternoon, you have a lot more power when the sun is really low. You'll keep that voltage nice and high. Next, the AC charger or the grid input, we have L1, L2. So you have to have a 120, 240 volt connection like a NEMA 1450 or something. You can do 5,500 watts. And it has a generator input. So you can actually use a generator to run your loads in a bypass configuration. And then from the generator to the load, the inverter will supplement that power. And this is the first model on the market, especially of this size, with that feature. Also, the load, you can actually supplement the 18K and call this a generator. So you can really mix and match and connect these all together in all sorts of ways. And that's a recommended configuration from the manufacturer. It's designed to actually do that. Next, it's small and it weighs only 50 pounds. If you compare this to a 6048, which also has a split phase output 6,000 watt inverter, but it doesn't have the same surge capacity, that thing is like this big and it's not as efficient, and it's 72 pounds. So, and the voltage, the max input voltage of that unit is 150 volts. So think about how far they've come in the last couple years. It's crazy. I'm not talking about brands here. I'm talking about the industry as a whole. Also, it has safety features that no one else has. GFCI and even arc fault detection on the MPPT. And it has its own disconnect, so it should be up to code. I'm not sure if it's certified yet, but I'm pretty sure they're going to be doing that. They usually don't add those features unless it's actually going to be certified to that standard. Anyways, that's enough talking. Let's open it up and see what's inside. And it's surprisingly simple. There's not a whole lot to say. Everything is labeled. We have 2 solar charge controllers. We have the communication board with battery communication right here. And then here's for the parallel communication. And yeah, battery connection, that's it. This is the same quality as the 18K's internals. You even have conformal coating, this to direct air, these massive inductors. How many inductors do they have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that necessary? All the connections feel really good too. And most of these plugs are glued down as well. And I don't see anything very cheap. Usually you can tell instantly when something's from the cheapest Chinese factory. This one looks pretty good. Now the one thing I dislike is how these wires are bundled right here and how far they're going to supply these inductors for the MPPT circuit. I think there could have been a better way. This looks messy and there's possibility of heat accumulation. These don't even look bundled that nicely. Look at all of these wires bundled with a zip tie. I don't like that. It doesn't look organized, and I think they could have reconfigured this whole system. It just looks like an afterthought. I mean, look at how close these are to the heatsink as well. I don't like that. I like no obstructions on my heat sinks, and I do not like bundled wires, especially when they have to go a long distance. If you think about how this is designed, I think they were just trying to make this very small. They could have opened this up and redesigned this PCB, but yeah, I think they were just trying to cram it all into a small spot. Now there is temp sensors on these heat sinks, and you have a big cooling fan right here. So I don't think it's going to affect performance, but I just like it being better. Now the moment of truth, we're gonna hook it up and see if it actually works. So So a week ago, I finished building this system. I used 2 server rack batteries connected in a diagonal configuration with 1/0 gauge cable. And then I added NEMA 1450 extension cord, a male and female, so I can charge and discharge with 120 to 40 volts. And then I also added 2000 watts of solar panels. And this system has been autonomously cycling every single day for a whole week. And I'm also charging my electric car with it for daily driving. Now the first thing we want to test is the idle consumption. So we're going to turn the inverter on and see how much power it draws. First we're going to turn off the output. We're getting 0.66 amps. At 52.8 volts, and that's 34 watts, so that means it's in eco mode. I'm going to turn the inverter off and back on again, and it should go up to 50 watts. Now it just switched on, and we are at 1 amp, so it's pulling 50 watts. Now let's turn the solar back on and the grid. Now we're pulling almost 6 kilowatts from the grid. If you take 5,580 and you divide it by the charging efficiency, you get exactly 6,000 watts. Also, I verified this with my Fluke meter, and the same is true for the discharging efficiency. So let me show you that. So first we're going to turn this off, and we're going to turn on the output. And I have a NEMA 1450 to a 650 to the Tesla charger. And now we're charging with 25 amps at 240 volts. And charging the Tesla is 98% of its output capacity. We're pulling 6.2 kilowatts from the battery and 2.96 kilowatts per each leg. Now the efficiency figure from the battery to the AC output is off by 1%. Typically, if I use the screen, it will say that it's 95% efficient, but if you measure it with a meter, you'll get 93 to 94% efficiency, which matches the spec sheet. Now, if we flip the grid on, let's see what happens. And now it's in bypass mode, so we have 6,000 watts going to the Tesla, and then we have 1.8 kilowatts going into the batteries. And for bypass, you can do 9,000 watts. Now let's flip off the load. Let's see what happens. Now the charge rate is increasing. Now we're charging with 5,500 watts. Now for the whole week, it's been autonomously running, and what that means is if solar power is available and it reaches a certain voltage after it's been discharged, it will turn itself back on again. And a lot of solar generators do not have this feature except for the Hysolus and now the Ecoflow Delta Pro. But even if you have a small amount of solar, you can still charge an electric car with this unit. It will just turn itself back on and off whenever it has power available. So whether you have a 2,000 watt array or an 8,000 watt array, you can still charge a Tesla. And you can charge with 25 amps at the output. But if you want to charge at night, you can connect it to the grid as well and do the bypass mode. So yeah, you can do pretty much everything with this thing. It's not grid interactive. It doesn't backfeed the grid at all. This is considered an off-grid inverter, but it has autonomy features like the more expensive inverters, which is really nice. But yeah, all the 6548s have that. That's a very basic feature for all-in-ones. But if you are stepping up from a solar generator, this can do a lot more. Except for the Hysolus, that thing is actually pretty cool. That thing can do everything that you want as well. So now we're gonna do some fun testing. We have this cable that I built. We have 2 heat guns, and we can connect it to a single hot leg. So we're gonna see if it can actually handle that 3,000 watts. So first we need to turn this thing off, turn off the solar, turn off the grid. And then I'm gonna turn off the grid at the panel to make sure that we do not have any voltage here. And then turn off the batteries. We should be good. And we're good. By the way, this looks ugly because these cables are awful. I'm never buying these again. Now we have power. Now here's one heat gun. And heat gun number 2, 3.1 kilowatts. That's 24.8 amps. So we're gonna run this for a few minutes and see if it trips. This does not have line balancing like the 18K. It only does 3,000 watts continuous. And with my meters, it says 2,979 watts. We could do a heat gun in a vacuum and see if it can handle that. All right, here we go. Yeah, it seems to handle that just fine. Now this one measures the inrush, so let's see what we get. No way. That was 39 amps. Let's add the other heat gun and see how large we can get this number. 48 amps. Now this unit does have a surge capacity of 12,000 watts, but that's only for 240 volt loads. When it comes to 120 volt loads, single phase, the maximum is 3,000 watts. There's no surge rating for a single leg. Also, they said in the test report the max that they could get was 28 amps, and we loaded this thing down with 48 amps. So it did really good, but I would not depend on this if you have to run large inductive loads on a single leg. If you have large inductive loads on 240 volts, this should run it just fine. For the next test, we have a 3 horsepower 240 volt motor, and the initial surge to get that thing moving is pretty excessive. It's actually more than my car lift. So we're gonna try to run it with this inverter and see what happens. So I'm gonna stand behind the wall and then turn this thing on. Now we have power. Ah, stupid phone. Meter is on. Here we go. Oh, it tripped it. It did not move though. Maybe it's improperly wired. The inrush was 65 amps, and that's 15,000 watts. Holy cow. That is a lot of power. That's crazy. All right, let's try it one more time. Everything looks good. It's pretty straightforward. Now, if the inverter circuit can't do it, let's see if the grid can. That will tell me if I wired it incorrectly or something else. So here's the grid connection, and we can measure the inrush and see what we need. Woo! 300 amps? Yeah, it's either improperly wired or something else is going on. That is ridiculous. Man, I don't like this motor. I think I'm gonna find a different load. This seemed smart at first, but I don't like doing this. Yeah, I'm gonna find something else. At least we got to test the breakers, but yeah, we're not testing the surge with this. This is just excessive. Now we have 4 shop vacuums, and these create a pretty massive surge. So on one leg, we're gonna have these 2 vacuums, and on the other leg, we're gonna have those 2. And we're gonna flip the switch and turn them all on at the same time. Then we'll use our meter to measure the surge. And this is the adapter that we're using. This is gonna be pretty loud. 55 amps. 55 times 240 is 13,000 watts. Let's try it again. I think I can get it higher. Let's add some heat guns also. 2 heat guns and 4 vacuums. No way. Oh, we tripped it. We got 55 amps, so around the same as last time. With those heat guns, it makes it more than 6,000 watts continuous, so that's what tripped it. It wasn't the surge. Yeah, that was 8,200 watts actually. Now for the final test, we're gonna have 2 car lifts in series because it has a 240 volt surge capacity, but not a single phase. And I already tried this car lift on a single phase and it did not lift. So maybe putting 2 of these in series, it will actually work. Now to ensure that both motors turn on at the same time, we're going to use a clamp to press the on button. And then we're gonna wire them up and flip it on with the breaker at the inverter. And here's car lift number 2, car lift number 1, car lift number 2. Turn on our meter. All right, here we go. Aw, it tripped it. And we got 60 amps. It's 14,400 watts. Let's try it again because it got really close that time. Now attempt number 2. Ah, it tried. You can hear the motor spooling up. But yeah, it's not going over 60 amps. What a bummer. So the surge capacity was good and bad. I did not see the 12,000 watts for 25 seconds that they advertised. So for example, I was running 8,200 watts, but that was only for like 10 seconds and then it shut down. So I challenged EG4 to post a video running 12,000 watts for 25 seconds. I really want to see you guys do that. But the instantaneous surge was really good, but it wasn't as good as a Hysolus. So I would say it's between like an Ecoflow Delta Pro and a Hysolus. It's good, but it's not great. Now EG4 in their testing, they actually told me that they have a 5.5 horsepower air compressor that pulls 91 amps. So again, I want to see that. Next, they also said they have a 240 volt air compressor that pulls 89 amps, and they can start that up just fine with this inverter. Now, if they post a video of that with the same firmware as my model, I would be very impressed. Now, when running the inverter at 99% of its continuous output rating, I could do that all day long with charging my car. Same with charging from the grid, I could do it all day long, never had a single issue. Also, charging from the grid and from solar at the same time and waking itself up. Again, I did it for a week, every single day, not a single hiccup. Next, the software, I didn't find any problems, but I do not like the display interface. I think it's confusing. I don't like the layout and where everything is. I also don't like where the error codes are and how to change the settings. If you're only using this inverter with Wi-Fi with the app and you're changing the settings with the app or with your computer, it's fantastic. It's just as good as the 18K. But when you're trying to use that screen, I think it's a little confusing and I think they could have done a better job. Next, the battery cable knockout hole, if you look at it, it's actually crooked. It's to the left. And it should actually be centered below the battery connection. And they actually told me about this. I didn't even notice this one, but they said that for all the ones being shipped out to customers, it will be centered right below the battery connection. Next, I only have one unit. I was unable to test the parallel communication capability and how it differs from an LV6548. They said that they're going to send one out so I can test that on video and see if it's easier. On the 6548s, you have two serial cables and it's archaic. It's ridiculous. They need to have a better way of doing it. So hopefully we can test out that functionality in the next video. And that's all I can think of. I can't think of anything else. Everything worked. It was actually a really good unit. But the biggest concern is the customer service and support from Signature Solar. I still have people complaining on the forum about that. So that's probably the biggest downside of this unit. If you want to buy this unit and you don't want to go through Signature Solar, EG4 will be selling these to Current Connected, so you can buy it from them as well. So if you want customer service and support that's very quick, I would go through them instead. Now, this is a new product and we're not sure about the longevity, and the software is new, but the hardware has actually been in the field for 5 years. They've actually been selling this unit in South Africa, and they've made large installations, small installations, and it actually has the lowest failure rate of any Lux Power device that they've ever had. And they even sent me a picture of one that has 103 megawatt hours on it. But that is crazy. That is a lot of megawatt hours through such a small unit. Holy cow. And they have quite a few right here. Here's another one with 53 megawatt hours. This is a completely different system. And they're using them to run well pumps. And that is, an inductive load. It's a motor. So that's a good sign. If they have a low failure rate and that many people using them for that long, that is a good sign. Now, even though this is an EG4 product, this is created by Lux Power. So I would compare this product to the other Voltronic products and other inverter manufacturers. Even though all these people relabel it, and you'll say, oh, I like SunGold inverter. Oh, I like Solarc. At the end of the day, look at the actual manufacturer. That will actually determine if it's a good or bad unit. What will determine your customer service and support is which distributor you buy it through. So again, if you get a Lux Power device through Current Connected, I don't think you can go wrong, unless you get software issues because it's a new product. But yeah, we will see in due time. Now keep in mind that this is not a grid interactive inverter. This is off-grid specific only. And if you compare this inverter to everything else on the market, it blows them away. Especially for the feature set. If we were to take from the Voltronic lineup the LV6048, which also has a 6,000 watt inverter and a large solar charge controller, that solar charge controller maxes out 150 volts, and that thing weighs 20 more pounds, has a higher idle consumption, you have serial cables for parallel connection, you have to update the firmware in the most antiquated way possible, and it costs more money. Like, who in their right mind would buy that over this? I don't know how Voltronic will be around if Lux Power starts making lots of these inverters. And it seems like their older models are better than the newer ones. It's like the newer ones have more problems and higher idle consumption. but the Lux powers are getting better over time, but the Voltronics are not. I don't know why that is. Also, compared to Mega Revo or that waterproof one that SunGold Inverter sells, like, think about the competition for off-grid specific. This thing blows them away. Now, my question for the future from Lux Power is, are you guys gonna make a smaller inverter? You guys have the 6 kilowatt, you've got the 12 kilowatt. Are you gonna make a 3 kilowatt to compete with that small yellow 3 kilowatt that Signature Solar currently sells? That thing is fantastic and one of my favorite inverters of all time. But if Lux Power also makes a 3 kilowatt of that, and it has the new software and interface and Wi-Fi connection, that would be a full lineup. That's all we would really need. So hopefully they watch this video and build that. That would be awesome. So yeah, that's pretty much all I can think of. If you have any issues with this product, please post it on our forum. We love to see any issues that you have so that we can try to fix them or find someone that can fix the problem. So thank you so much for watching, and I will see you in the next video. Bye.